Okay guys, so now let's move to question 4.2. And again, just before we go any further, I just want to indicate to you guys that remember to hit the subscribe button and also the like button if you enjoy the content. So for those of you who are new to our channel, I would like to just take this opportunity to welcome you guys. So without any waste of time, just before we get to question 4.2, there's a statement there which says the block moves eastwards at 0.7 meters per second after the bullet has emerged from it. So as you can see there, I've actually wrote that value when I was going through the question paper. And again, I've just noticed that we're actually given the mass of that bullet, which is, let me see, it's 0.015 kg. So that's the mass of the bullet. So I think we are now good to go. So let's see. The question says, calculate the magnitude of the velocity of the bullet immediately after it emerges from the block. So before we can go any further, guys, it's very much important that you understand the question. And by understanding the question, it obviously means you should know exactly what it is that you are required to calculate. So the question says calculate the magnitude. The magnitude, the word magnitude and value, you can just refer to as one and the same thing. So when they say calculate the magnitude, they have not yet specified the value of what. So as the question continues, they say calculate the magnitude of the velocity. So you now have an idea of exactly what they want you to calculate. They want you to calculate the value of the velocity, meaning your final answer should be in meters per second. So in this case, guys, we are not in any way answering the question. I'm just training you on how to analyze a question, on how to understand a question, to know exactly what it is that is expected of you, so that before you even try to answer the question, you already know exactly how your answer should look like. So now we know we are calculating the velocity. Obviously, our answer should be in the SI unit, meters per second. So let's continue with the question. So now they're saying the velocity of the bullet immediately after it emerges from the block. So that means they want you to calculate the final velocity of the bullet. I think this is a straightforward question, guys. Obviously, you know the formula for calculating the momentum. So I'll just write down the formula. It's the sum of momentum initial, it's equals to the sum of momentum final. So this is a general formula for calculating a momentum in an isolated system. So we can expand this formula using the information on that diagram, on the given diagram. So now we know that momentum P is equals to mv. That we know, I think from grade 11. So now let's assign the bullet and the block the descriptions. So obviously we know we've got the mass of the bullet. I just noticed something that I would like us to agree on. So can you see we've got a bullet and a block, and both of them, they've got a their first letter starts with B. So we might use capital letter B and a small letter b just to differentiate those B's. So because B is small and block is big, let's just use small letter b to refer to the bullet. Then capital letter B will refer to the block. So now we've got the mass of the bullet multiplied by the velocity of the bullet. So this is the initial velocity. That's why I've got BI. Plus, remember on the formula is the sum of momentum. So we've got two objects. So this is the first object. We're going to sum it with the second object, which is the mass of the block multiplied by B, which is the velocity of the block, capital letter B initial. This is equals to, then we are there. We move to the final phase of that scenario. So we've got the mass of the bullet multiplied by the velocity final of the bullet plus the mass of the block multiplied by the velocity of the bullet. I think no, the velocity of the block final. So I think so far it makes sense, guys. I'm not sure if I lost some of you along the way. I know it could be a little bit confusing, but as I always give my student an advice is that just try to replay the video until it makes sense, because I'm 100% sure that I haven't missed anything so far. I might have been confused a bit, which is normal, but in the end I've given the information that I wanted to actually bring it to your attention. So now let's continue, guys. So obviously the next step is to substitute all the information that we've got. But before we start with the substitution, can you guys see exactly which variable along that formula are you expected to calculate? Can you see? Let's see. Obviously, we concentrate on the final part of that scenario, and you are required to calculate the velocity. So is it the velocity of the bullet? Is it the velocity of the block? I think as the velocity of the bullet. So that means this is exactly what we are required to calculate, meaning we should be having the information for all of these. Okay, let's see. Have we got the velocity of the bullet? We do. What about the mass? We do have. Let's now substitute on the formula. So in brackets, you've got the mass, which is 0,015. You've got the velocity, which is 400. Remember, guys, a velocity in physics, we measure it in meters per second. So if it was given in kilometers per hour, you had to convert it to meters per second. So now let's move to the block. We've got the mass of the block is 2 kg, but the initial velocity is 0. It's equals to mass of the bullet. We do have it's 0.015. This is exactly what we are calculating, plus mass of the bullet is equals to 2 velocity of this is the mass of the block. Velocity of the block final we are given it's equals to 0.7. So I'm not sure why I get confused on that last part where I refer to the bullet, but I'm glad in the end I managed to notice my mistake. So I may have made a mistake when I explained, even though I managed to correct it. But in terms of substitutions, guys, you should make sure you never make any mistake, because that will cause you as you calculate. So in physics, guys, I usually don't take that long in terms of calculations, and again, I don't go through all of those mathematical steps because I cover most of that stuff when I do maths. So obviously, that's why maths and physical sciences they go hand in hand, because physics, it's even easier because you identify the formula, you write it down, you substitute, and then from there you just solve for the unknown. So I'll just explain to you exactly what I'm going to do from there. It's fine, I'll just show you on the calculator. So I'm just going to punch all of this. Obviously, the answer to all of this, I will just work it out with this 2 times that velocity. So it's more like I'm going to punch all of this, subtract this, divided by this. So the value that I'm getting, it should be velocity of the bullet final. And remember, guys, as we discussed, our final answer should be in meters per second. And for the fact that this bullet managed to pass through the block, it means it will continue to move in the eastwards direction. Only if it bounced, then that would mean after hitting the block, it moves in the opposite direction. So that means it continues to move eastwards. What does it mean? It means our answer should be positive. I'm not sure if you understand. This part, it's not that much important. I'm just doing this so that you have an idea of to what extent you should go deep in terms of analyzing the situation. So it's not just, let me say, for me, it's not just a matter of calculating and giving you the final answer. I just make sure that all of that comes with extra tips, which actually helps you in case if you had an information which was scattered. You can then make use of that information, group it together, and form a solid understanding. So let's see. So I'll just do the calculation part. I hope you can clearly see. Let's see. So in brackets, I've got a 0.015 close into 400. Remember, guys, this part, it's actually 0 because it's 2 multiplied by 0, which is 0. So I can just decide to ignore that part on my calculations and say it's equals to, then I get 6. Remember, that 6 I subtract with that part. So it's minus into 2, 0.7, it's equals to, then it's 4.6. So it's more like 4.6, it's equals to 0.015 V of the bullet final. That's why at this stage I divide by 0.015. As I've indicated, guys, this answer, it should be a positive answer, and again it should be less than 400 meters per second. So there are high chances that it could be 300 and something. So let's see, it's equals to, there, can you see? So we've got an answer which is positive, and again it's less than the initial velocity of the bullet. So in that way, guys, we are done with this question. And of course, I won't miss that part that you've been waiting for. Let's see. This question is allocated, let me see on the question paper. So this question is allocated 4 marks. It's allocated 4 marks. So I'll just quickly show you how we mark this question. So let's see, guys. Obviously, we give you a mark for writing the correct formula, which is what I like about physical sciences. For you to just copy the formula from the formula sheet and writing it down to the relevant question, we give you a mark for that. And again, we give you 1 mark for substitution. 1 mark for substitution. So that means it's 1 mark for correct substitution on the initial side and correct mark for substitution on the final phase. So obviously the 4th mark, you get it for writing the correct answer with the correct SI unit. So that's how you score 4 marks. So I hope you guys enjoyed this lesson and it makes sense. So I think without any waste of time, we can now move to question 4.3.